Hello, this is Hart Hagen. Let's talk about how forests are not just carbon. Trees are not just sticks of carbon. And so we'll see if my video is okay. It looks like my video is struggling, but we'll try to get through this. So the idea is that climate change has been captured by a kind of a story. The conversation around climate change has been captured by a story. And the story says that, climate change comes from the burning of fossil fuels, which emitted too much carbon dioxide. And the only thing we have to think about is how to reduce the carbon dioxide in the atmosphere. One problem with that is going to take a long time. In the very best scenario, it's going to take a very long time to do that. But the other main thing about it is that there are things that affect the climate that have little to do with carbon dioxide, and they're very powerful things. Mainly, they're called plants, they're called trees, they're called forests, which have many different positive impacts on the climate. And conversely, when you remove the forest, when you remove the trees, then you no longer have those benefits. And this video is about all the different things that have benefits to our forests and benefits to our climate. So let me show you something that I brought, and it is, this is a slideshow. It's called Forests Are Not Just Carbon. Trees and forests have many benefits. They are not just storehouses for carbon. This report from the World Resources Institute describes the many benefits of forests for cooling our temperatures, regulating our temperatures, and driving rainfall locally, regionally, and beyond. So let me go over here. Now, these are the main things that trees and forests do as they're interacting with the water cycle. They cause evaporation, because lots of water is evaporating from the trees and from the forest. They cause condensation because when the trees and forests are evaporating water, they are also emitting what's called condensation nuclei. This can include bacteria, it can include organic compounds, it can include fungal spores, it can include pollen. All of these things are solids that, like say this is a solid object, and here's water vapor. That water vapor has to cling to a solid object in order to condense. And the solid objects that cause condensation, many if not most of them, come from trees and forests. So we need those trees and forests to emit the solid objects called condensation nuclei, so that then condensation can occur. And then when you have condensation, this causes cloud formation. When you have clouds, then you can have precipitation. So evaporation, condensation, cloud formation, and precipitation are the four major aspects of the water cycle that is caused or driven by trees and forests. If you take away the trees and forests, you no longer have these major aspects of the water cycle, or at least you have them in diminished quantities. Now, a forest also becomes at least 9 things, probably many more, but at least these 9 things in relation to water. As it interacts with water, it becomes a sponge, which means it soaks up the rainfall. If you remove the forest, you remove the sponge, you no longer have something that can soak up rainfall. A forest is a filter, in that it's both an air filter and a water filter. It filters the water because it slows down the water, and when you slow down the water, you give it much more opportunities to filter out those particles. The trees, the plant matter, the roots, the soil with carbon in it becomes a filter. And then the trees above ground becomes a filter for the wind, because the wind comes along, the wind has dust in it, in the surface roughness, if you will, of that forest. It gathers up the dust. Therefore, it's an air filter. A forest becomes many more things that we won't talk about all of them, but it becomes a heat bank. It becomes a storehouse for heat, meaning the surroundings are going to cool up slower and cool down slower so that you have less in terms of high extremes and low extremes in temperatures. The forest becomes a cooler because you have so much evaporating water. The forest becomes a humidifier because you have so much evaporating water, and that humidifier keeps the soil from drying out. It becomes a canopy. If you take away the forest, you take away the canopy. Canopy meaning kind of like an umbrella. It blocks the sun. It protects the plants and the soil from the harsh rays of the sun. It becomes a windbreak. It slows down the wind. It becomes a biotic pump, which is a living system that kind of draws water to itself. This is kind of a new but very solidly grounded theory from Anastasia Makareva and her late colleague Viktor Gorshkov, who discovered the biotic pump theory. Forests, when they're fully functioning, literally bring rain to themselves because of condensation creates a vacuum, bringing stuff in. Condensation creates another vacuum, then precipitation, more condensation, precipitation, and it draws water in. And lastly, a forest becomes a habitat for all kinds of living things, including fungi, including bacteria, including plants, including animals, including insects, all of which are necessary in climate regulation. So a forest becomes all these things. Now, we're going to look at a report called Not Just Carbon, capturing all the benefits of forests for stabilizing the climate from local to global scales. Let's look at a few of these. Trees drive cloud formation. We already talked about that, but trees drive cloud formation. And the report, this is my paraphrase of part of the report. It's not only do growing trees pull significant amounts of carbon out of the atmosphere, but by encouraging cloud formation through their moisture releases and surface roughness, they ensure that more energy from sunlight is reflected back into space. Forests transport moisture, according to the report. At the regional level, large expanses of forest transport moisture across continents through evapotranspiration. So you have a forest that through that biotic pump, it pumps water across regions. Much moisture transport because of the forest. Deforestation risks disrupting rainfall patterns because forests are doing that moisture transport, and therefore deforestation risks disrupting rainfall patterns and thus water resource availability in distant geographies. Forests prevent extreme temperatures. Locally, forests moderate temperature extremes with important implications for human health and agricultural productivity. Evaporating water creates a cooling effect. So let's stop midstream and just talk about what we've talked about so far. Forests have many functions in relation to climate other than just storehouses for carbon. Yes, forests store carbon. They are able to absorb and hold monumental amounts of carbon, but we're not seeing the whole picture if we just see them as storehouses for carbon. They have many functions as they interact with water. They cause evaporation, they cause condensation, cloud formation, they cause precipitation because they are cool places where the rainfall can fall into, as opposed to a hotter place is less likely to be able to accommodate and, if you will, attract rainfall. And a forest becomes a filter, a heat bank, a canopy, and many other things. And so we're just talking about all of the things that the forest becomes as it interacts with water. And therefore, we need to understand all of the things that are lost when we cut down a forest. Because for one thing, there's this theory, it's pseudoscience, it's bad science, but there's this theory and there's this propaganda that says when you cut down a forest and plant new trees, then they're absorbing carbon faster because new trees grow faster and therefore they're absorbing more carbon. It's just simply not true. Older trees absorb more carbon. Trees absorb carbon, more and more over the course of time until they die. And then if you allow the dead wood to stay there, then it becomes a part of a cycling. Yes, there's going to be some carbon dioxide emissions as a result of decay, but also there, some of that organic matter feeds back into the soil, and good soil is a tremendous storehouse for carbon. So we have many benefits of forests. Let's read on in the report. Evaporating water creates a cooling effect. Reading from the report, in the same way that our body feels cooler after a swim as water dries off your skin, evaporation and transpiration also carry heat away from leaves and forest surfaces, leaving the surface and near surface atmosphere cooler. How much forest area have we lost? The FAO, that's the Food and Agriculture Organization of the United Nations, estimates that 10 million hectares of forest, mostly natural forests and mostly in the tropics, have been lost annually from 2015 to 2020, compared to 5 million hectares of forest expansion, mostly in the north and mostly plantations and planted forests. So we've lost a lot of forests. We don't regain all that we've lost. How many billions of tons of CO2 have emerged from forestry and other land uses? I'm going to skip over this just because, let's just say lots of CO2 has emerged from forestry, which means, timber. The timber industry wants to call itself, they want to say they're doing forestry. No, they're cutting down trees. But anyway, even old growth forests absorb carbon, so removing forests removes a carbon sink. Healthy forests, even very old and undisturbed forests, continue to absorb carbon from the atmosphere, so every hectare of deforestation is not only an emission, but also the loss of future sequestration. Does rainfall decrease in forested areas? Studies generally agree that rainfall decreases in forested areas, although the effect on nearby precipitation changes can be complex. The effect on nearby precipitation changes can be complex. So yeah, it's complex, but generally speaking, rainfall decreases in deforested areas. Therefore, rainfall would be steadier if we did not eliminate the forest. How does deforestation affect surface temperatures? The loss of surface roughness and complexity from deforestation can increase horizontal wind speeds. In other words, when the forest was there, it was slowing down the wind, but you remove it and the wind speeds up. As a result, you reduce the mixing of near surface air, leaving land surface drier and warmer. In other words, you used to have this cooler air at the surface that was mixing with the air above it, keeping the air above it cooler, but now you don't have that mixing. You don't have that forest acting as a windbreak and an air filter, so the land surface is going to be drier and warmer. Together, these various particles and compounds, bacteria, so this is kind of shifting to another topic all of a sudden, but together these various particles and compounds, bacteria, pollen spores, organic compounds, affect the formation of clouds, including their presence or absence, their altitude, and their reflective properties. So the forest nurtures clouds, the forest protects clouds, the forest causes clouds to form, and if we want more clouds, we will leave our forests more intact. And it's not about planting trees. It's not how many trees we plant, it's how many trees we don't cut down, because we can cut them down much faster than they grow. Do forests provide climate benefits? One more slide, and then I think we'll fast forward to the end. All forests provide local climate benefits through biophysical processes. Deforestation exacerbates temperature and moisture extremes, while reforestation buffers them. Okay, does deforestation change rainfall patterns? Let's just say yes. I mean, they're looking at places like, in Brazil. Brazil contributes rainfall to the rest of South America, Argentina, Bolivia, Paraguay. And so let me read you my conclusion, and then the conclusion is, I'll show it to you on the screen. Forests are not just places to store carbon. They also regulate the climate and drive water cycles by casting shade, transpiring huge amounts of water, slowing the wind, and emitting particles and compounds that cause precipitation. Deforestation eliminates all of these functions and benefits. So the upshot is forests have many benefits. And, life is fascinating. Life is complex. And what we've been doing for time immemorial, especially 5,000 years ago, the birth of, that's when agriculture really started in earnest. And what we've been doing is just we've been eliminating life. We've been eliminating our ecosystems, eliminating forests, eliminating water cycles, and eliminating habitat for the animals, the plants, the fungi, the bacteria, protozoa, the nematodes, the worms, the earthworms, the pill bugs, the centipedes and millipedes, the ants, the beetles. We've just been eliminating their habitat. We need to stop doing that. And, and if we stop doing that, we're going to have a cooler climate. We haven't even begun to understand or implement. We haven't begun to understand or implement all of the benefits that would be available to us if we just stopped destroying nature. And we can do that, but we need to, wrest control. Right now, a few people control everything. We're supposed to have this big democracy, but we don't, because if you have a few people controlling everything, that's not a democracy by definition. So we need to walk the talk. We need to enact the democracy that we give so much lip service to. That's all. Thank you for joining me. Have a great day.